Hello, Calculus. I want to first preface this by saying this is the first video I'm making not at DSHA, and I have this little tablet, but it's not really that good at writing, so please forgive my terrible, terrible writing skills during this time. All right, our next section is integration by parts, which is not actually 7.2. We're just going to do this by topic from here on out. And this is sometimes known as the product rule for integration. Why? Well, this is a rule we can use where's my pen? When we have two things multiplied together. So here is probably the most important thing that's going to be on this slide. If you take no notes, just make sure you write down this thing right here. So the integral of some function u with respect to v is equal to u times v minus the integral of v du. And I realize at this moment that seems a little weird, so please just stick with me through this. I will do an example, and I think it'll probably clear some things up. The important thing about integration by parts is that we are the ones who choose what every piece is, meaning we have to decide what of our original problem is our u and what of our original problem is our dv. So let's talk for a second about choosing a u, because that's going to be kind of our starting point here, selecting our u. So let's talk about that. For selecting our u, we are going to do it in a certain order. So it's often an acronym LIATE, which I know doesn't really mean anything. If you want to give it a meaning, please let me know. But this stands for the order in which we should choose our u. Choose u. How? We're going to start with the L. So the first letter L stands for logarithm. Oops, well, pretend that's a THM. Logarithms. If you see something in your equation like the natural log of x or log of x, that should be your u right away, right off the bat. That's our first. That's the L in LIATE. Next we have I, which stands for inverse trig. But if I'm being quite honest right here, the inverse trig is not really something that we are going to come across a ton in our class, mostly because, let's be honest, we're in COVID times. It's not all that important. However, that would be something like arc tangent of x. Remember, we can write inverses like that, or you can write tangent inverse to the -1 of x. If you see anything like that, that would be inverse tangent, or excuse me, inverse trig. Like I said, though, we're not really going to deal with that in this class all that much. So that's LIA. Next is A. So if you don't have any logarithms, you don't have any inverse trig functions, the next thing you would choose to be your u would be algebraic. All right, so that's our A. This is anything that would be like a polynomial. So that'll look something like if you just have an x cubed, or if you have a 4x squared, or anything like that would be our algebraic. We don't have algebraic in our function, then the next letter T stands for trig, trigonometric. So not inverse trig, this is just any normal trig function. So this would be just sine of x, cosine of x, etc. Sine of x, cosine of x, etc. LIATE. And last but not least, if you have none of these in your equation, the last thing you could choose for your u would be exponential. Exponential. So that's the E in LIATE. Again, you would only choose exponential if you don't have a log, an inverse trig, an algebraic, or a normal trig function. But exponential, we're talking about something like 6 to the x power. All right, like I said, these are guidelines for selecting your u. You're going to choose it in this order. However, there are some general tips. I think I'm just going to type these. It'll be easier to do that. So for choosing your dv piece, This should be something that, oh my goodness, something that can be easily integrated. And for choosing your u, this should be something whose derivative is easier than u itself. Right now, you might be reading these tips and thinking like that makes no sense, and I get that. That it is kind of vague right now. So, like I said, just stick with me and maybe take these notes, and we'll do an example in just a moment to kind of clarify all this. But the general how this is going to work, we're going to pick our u, we're going to pick our dv, and then if you notice in our formula right here, we pick something in our original problem to be our u, and we pick something to be our dv. Now we also need a v and a du, which means we need to take an integral and a derivative. Then we plug it all back into that equation, and we get a much easier version of something we can take an integral of. Let's try a problem. Let's do this right here. At the beginning, I said this is kind of like a product rule for integration. If you notice, this original problem has two things multiplied together, x cubed times the natural log of x. That would be what I mean by product rule. So if you ever see something like that, you might consider, hey, integration by parts. I know that this is our general equation that we want to use. And so we first need to start out by deciding what part is my u, what part is my dv. If we think of our little Liate, it suggests the first thing you should choose for your u would be any logarithmic functions, which means, hopefully you're playing along at home, u in our case should be the natural log of x. That means that dv is everything that's left over. So the x cubed times dx. Really, if you want, we can take our original function and kind of rearrange it. So technically we're looking at the integral of the natural log of x times x cubed with respect to x. That maybe is more obvious then, because we have our u, our natural log of x, and our dv, or x cubed times dx. All right, so if we want to continue, like I was saying, we have, if I look over here, we have our u already, that's the natural log of x, but we don't have a v, which we need. How do we get v? Well, we have the derivative of v, which means we need to take the integral. So the integral of both sides is technically what we're doing. We're integrating both sides, x cubed with respect to x. The integral of nothing, technically there's just a 1 here, would be v. And the integral of x cubed, think about it for a moment, pause the video if you want. Otherwise, the integral of x cubed, the antiderivative of x cubed, would be 1/4 x to the 4th power, technically plus c, which we can or cannot, doesn't really matter if we don't write it. So now we have our v piece right here and right here, and the only other thing we need is our du. All right, which means we need to take, I'm going to put this down here, sorry, the derivative of u, which is not super challenging here. The derivative of natural log of x is 1/x with respect to x. All right, I'm sorry, that's going to seem like magic. I just paused the video and kind of rearranged things. I have not deleted anything from this page. I just made it all in one nice little space. So to recap, we decided what u was, we decided what dv was, then we took the derivative of u and the antiderivative of dv, and we calculated du and v. Now we can put it all back in to our integral. So Remember I said if there's nothing else you remember, make sure you write down that thing. The integral of u dv is equal to u times v minus the integral of v du. I'm going to now plug in all of my pieces. Plug in all my pieces, which means I have u, we decided was the natural log of x. V is 1/4 x to the 4th minus the integral of v, which again is that 1/4 x to the 4th times du, which is 1/x with respect to x. Now we have a much easier thing to take an antiderivative of. And you might be thinking, that doesn't look very easy. Well, let's clean it up a little bit. All right, so on this left side, I don't have to do anything with this. I'm really just going to rearrange it a little bit. I'm going to make it x to the 4th times the natural log of x all over 4. Notice all I did was make it all over 4 by multiplying the common denominator, or not the common denominator, multiplying the denominators. And I moved the x to the 4th out front. The other thing I'm going to do before I take my antiderivative is I'm going to move this 1/4 out front. It's just a coefficient. I don't need it. And I'm going to simplify x to the 4th divided by x would really be x cubed. And this is all still with respect to x. If I look at that, that is significantly easier than what we began our problem with. Now I'm really just taking the integral of x cubed, which actually we have already done. So I finished my problem by keeping nothing's going to change right here, x to the 4th natural log of x all over 4 minus, I have this 1/4, I'm not going to do anything with that yet, and the antiderivative of x cubed would be 1/4 x to the 4th power all plus c. And then technically my last step would just be to simplify this little bit right here, which would give me a final solution of x to the 4th times the natural log of x all over 4 minus, oops, I'm going to undo that, x to the 4th times natural log of x all over 4 minus x to the 4th all over 16 plus c. That is my solution, my final answer. Let's say you don't believe me, which is totally fair. If you want to check your work, you would take a derivative. If you take a derivative, you should come back to what we started with at the beginning. Remember, if you choose to do this, that top right there would need a product rule to take a derivative of. I'm not telling you you have to do it, but you definitely could. All right, we're going to do one more example together in this video, and here is our next problem, the integral of 3x e to the negative x, all with respect to x. So remember, this is our general formula we are going to follow. We first need to decide what is our u and what is our dv. So we think through Liate. L, logarithms, there are none. I, inverse trig functions, there are none. A, algebraic, hey, there is. That means my u is going to be 3x, and my dv is everything else, e to the negative x with respect to x. If I want to actually do this, I need to start by taking the derivative of u. The derivative of 3x is just 3 with respect to x, and I need to take the antiderivative of dv. That means v is equal to, take a little bit of time right now, pause the video, to take the antiderivative of e to the negative x. Otherwise, v is equal to negative e to the negative x, technically plus c. If you need help with this antiderivative, please ask. Send me a message on Teams or an email. I would be happy to help. Otherwise, we now have all the pieces we need. We can plug them in to our formula. So our original problem was the integral of 3x e to the negative x all with respect to x, that's equal to u, which was 3x, times v, which is negative e to the negative x, minus the integral of v, negative e to the negative x, times du, 3dx. Now we just need to clean things up a little bit. I am going to start by just rewriting this first piece as negative 3x e to the negative x. I'm also going to pull this negative, here, I will highlight what I'm doing. I'm going to pull this negative and 3 out front, so I really have a plus 3 times the integral of e to the negative x with respect to x, and maybe, just maybe, you notice that this integral right here is the same as the integral we did over here. Technically, it's exactly the same equation, which is really good for us because we then can quickly know that the answer would be negative 3x e to the negative x plus 3 times negative e to the negative x, all technically plus c. And again, the only other thing I'm going to really do here is make it look a little nicer. So negative 3x e to the negative x minus 3 e to the negative x, all plus c. If you want, you could definitely factor out a negative 3 e to the negative x. It doesn't necessarily make it any better, but you could do that. If you need clarification, either take some time, pause it, watch this video again. Otherwise, ask me and I would love to help. Your worksheet is online. Good luck, ladies.